Okay, now it's your turn to have a go. Sketch this graph here. Um, yeah, try to investigate what happens when x is really big. Which term dominates? Here you could visualize it as one term, one term, one term, and one term. And when x is small, you could when x is small, this might be dominant. So which means you could say it's a straight line. But merge these two together. So because we're pretty much we are pretty good at drawing straight lines. So this is like y equals mx plus c. C in this case is 3, and this m here is 1. So basically, you can merge these two together. So when x is small, these two dominate. So you can visualize it as like that. Okay, and yeah, just try and well anyway, do whatever you have to do. Press pause and have a go. Sketch this graph. So press pause and have a go. Okay, so well when x is let's see when x is big, if you put 99999 into here and into here and into here, well, this term here would be so big in comparison to these three terms, you can actually forget about these three. So when x is really big, it wants to follow this. And same with negative 99999. If you put this into here, this term here will be so big in comparison to these three, you can forget about these three. Now when x is small, yes, you could just say, oh, when x is small, these three would disappear and just look at the three. So it would be a straight line like this. But actually, it's better to merge these two together. So visualize it as this. It's going to be a straight line with an intercept of 3 and a gradient of 1. So visualize it like this. A gradient of 1, intercept of 3. So this is 3. Now when x is big, it wants to do this. Okay, but well, you just got to, well, actually realistically it wants to do this. It's steeper, but so here, when x is big, it wants to do this. Okay, but you got to compromise here, because when x is small, it will want to do this. So you just got to join up the two bits like this. So if you were to sketch this, it will look something like this. Okay, because it has to go through here, and when x is big, it wants to do this graph here. So you just got to join up the two. Now, if you were to plot this on the graph plotter, it would look something like this. You see, when x is small, well, don't forget this is y equals x x cubed plus x squared plus x plus 3. You see, this point here is 3, and it has a gradient of 3. It wants to do this, and when it's big, it wants to do this. So when it's big, it actually wants to do something like this. But when well, anyway, when if you look at when x equals, well, when x is big, it wants to follow y equals x to the power 3. So it wants to do this. Hang on, it wants to do this. Hang on. But when x is small, it has to obey this bit here. An intercept of 3, a gradient of 1. So it has to compromise. That's why it's like this. The important part is this, and it wants to obey the x cubed, which is something like x cubed, which is something like this. Okay, so it's just merging the two together. So it should look like this. Okay.